Good morning everyone. I'm Maheswari, EP department. This video I'm going to discuss about the subject sensors and transducer in that fourth unit. So in the fourth unit we are going to see the topic about optical, pressure and temperature sensor. So in this particular unit 4, the today's discussion of topic is about photovoltaic cell. So this photovoltaic cell photovoltaic cell. It is a semiconductor device and it is an active transducer, and it is used to convert the light energy into electrical energy. In this photovoltaic cell, the current starts flowing into the photovoltaic cell when the load is connected to it. Either the silicon and selenium are used as a semiconductor material. When the semiconductor material absorbs heat, the free electrons of the material starts moving, and this phenomenon is known as photovoltaic effect. The movement of the electrons develop a current in the cell, and the current is known as the photoelectric current. Now the layers of the photovoltaic cell. So construction layers of the photovoltaic cell. The photovoltaic cell, it consists of many layers of material, and it is each layer is for specific purpose. The most important layer of photovoltaic cell is the semiconductor layer. So it is comprised of two distinct layers, that is the p-type layer and the n-type layer. So this is the diagram shows the p-type silicon and the n-type silicon layers. Okay, and it is converts, and this layers converts the sun's energy into useful electricity through a process, and this process is known as photovoltaic effect. So here in this on either side of the semiconductor layer, we have a conducting material which collects the electricity produced. So it is, we are able to see that nickel plating, the positive terminal and the negative terminal, and is connected to the load as shown in the diagram. Now, at the back side or the shaded side of the cell, it is used to afford completely the covered portion of the semiconductor, whereas the front side or illuminated side uses the conductors in order to avoid the blocking too much of sun's radiation from reaching the sun semiconductor material. And the last layer, which is applied only to the illumination side of the cell, is the anti-reflection coating. This layer, anti-reflection coating layer, and all the semiconductors are naturally reflective. The reflection loss will be significant here. The solution to this is to use several layers of anti-reflection coating and to reduce the amount of solar radiation that is reflected off the surface of the cell. So what is photovoltaic effect? It is the effect which it is a process which generates the voltage or electric current in a photovoltaic cell when it is exposed to sunlight. The solar cells are composed of two different types of semiconductors, a p-type and an n-type, and they are joined together and they create a p-n junction. Now, by joining these two types of semiconductor, an electric field is formed in the region of the junction. And so, in the region of junction, now what is happening? The electrons move to the positive p side and holes move to the negative n side. This field causes the negative charge particles to move in one direction and the positive charge particles to move in the opposite direction. This light is composed of photons, which is nothing but small bundles of electromagnetic radiations or energy. When the light of suitable wavelength is incident on these cells, the energy from these cells is transferred to the electrons of the semiconductor layer, and thus causing those electrons to jump to a higher level, so higher energy state, and it will jump to the from the valence band to the conduction band. So in their excited state, that is in the conduction band, these electrons are free to move through the material, and this motion of the electrons or movement of the electron that creates an electric current in a cell. This is the working of this photovoltaic cell. So this is how the when the light flows, the movement of current is shown in this diagram. Working principle diagram, how the free electrons are traveling through this layer. Next, characteristics of the photovoltaic cell. So when you observe the characteristics of the PV cell under normal condition, solar cell is the product of the current and the voltage. When the solar cell is open circuited, it is not connected to any load, the current will be minimum and the voltage across the cell is at its maximum, known as an open circuit voltage, or it is represented as VOC. And when the solar cell is short circuited, that is the positive and negative leads are connected together, the voltage across the cell is at its minimum 0 and the current flowing out of the cell reaches its maximum, and this is known as, and there is a current flow, this current is known as short circuit current, it is represented as ISC. The solar cell IV characteristics range from short circuit current ISC at the 0 output volt to 0 current at the full open circuit voltage VOC. So the maximum voltage available from a cell is at open circuit and the maximum current at the closed circuit. So neither of these conditions generates any electric power, but there is a point wherein between this solar cell generates maximum power. So there is one particular combination of current and voltage for which the power reaches its maximum value, that is at IMP and VMP value. So this is the point at which the cell generates maximum energy power, and this point is represented as the maximum power point, MPP. It is represented as MPP, maximum power point. So, if ideal operation of photovoltaic cell is defined at the maximum power point. The maximum power point of a solar cell is positioned near the bend of the IV characteristics. Since solar cell output voltage and current both depends upon the temperature, the actual output power will vary with respect to the temperature. So, till now we have seen about the solar cell and the IV characteristics of it for a single cell or a panel. But many photovoltaic arrays are made up of smaller PV panels connected together. And the IV characteristics of PV array is just scaled up version of this single solar IV characteristics. The solar panel IV characteristics. So the photovoltaic panels can be wired or connected together either in series or parallel combination or both to increase the voltage or current capability of the solar array. If the array panels are connected in series combination, then the voltage increases. And if the connected in parallel combination, the current increases. The electric power in watt is generated by these different photovoltaic combination, and it is the product of voltage and current. P is equal to V into I. So the solar panels are connected together and in such a way that they are operated in such a way that the maximum power point tracking is obtained. So in this video we have seen about the construction and working of this solar cell, it is the photovoltaic cell, and the IV characteristics of it. Thank you everyone.